In general, they're called alpha. Yes, alpha is the first carbon, and the second carbon is beta. Okay, the alpha protons here are acidic, yes, and they can be pulled off with different bases depending on what they are. Now, some of these reactions might be equilibrium reactions, which means they go forward and
backwards,
go reverse. Okay. Now, some of these reactions I can say, when I said last time irreversible, what I meant to say is that it goes towards the right. It goes towards the formation of the enolate. Yes or no? And I told you that irreversible most of the time meant LDA and sodium hydroxide. LDA because of a very large difference in pKa. Meaning that LDA is so much more less acidic than the other one that is never going to go reverse. And H2 is because of hydrogen gas. Okay? So, I can pull a proton off from here. And enol formation occurs in two different ways, yes? Enol formation occurs via an acid or a base. Now, I am not showing you all the time, we already did this, either an acid or a base. Yes or no? Yes. If it is in an acid, what you are going to get is, what is it that you're going to get?
Double bond.
Is that the enol? Yes or no? Enol. This is the enol. This is called enol, and this is called ketone. Yes? There is an equilibrium between these. Equilibrium. Yes or no? Now, when I say irreversible, I mean to say that the equilibrium lies to this side, which is what we need to react. This won't react. This will react. And not even on this type of structure, it will react, like I told you before, in this type of structure, yes? But let's not say that. Let's talk about the enol. Okay, that is under what conditions? Under acidic conditions. But under basic conditions, we still have formation of the enolate, but now this time, this is enol, and this is, what's this? It's not enol, but it's enolate. Just like carboxylate, yes? Yeah. Just like acetate. Okay, that's the enolate. Do they react in the same way? Yeah, same way. So sometimes I may use H3O plus, or I may use sodium hydroxide. Okay? If I use H3O plus and Br2, what's the product that you get?
The BR.
It's called the alpha halogenation. Yes?
Yeah.
So if I have this, and now when I am here, right? On the first step you add this or this, and on the second step you add Br2. And what happens is alpha halogenation. Yes or no? And I showed you the mechanism for this, didn't I? Karen, did I show you the mechanism for this? What do you mean you don't know?
It's not in the book, but I don't know what she's talking about. Yeah, you did.
You don't have my notes?
I'm observing. And then I take some notes.
Oh, you take some notes? You don't take all notes? I'm going to get tricky on the next test. I am maliciously going to try to hurt you. What did you say, Sophia?
Huh?
What did you say? You have it in the notes?
I said it.
Oh, you said it? Okay. And did we do elimination?
No.
No. We did
Wait,
do
actually
elimination.
we did, yes.
I am sure we did it because I remember the precise moment in which I did it.
You were about to go into the bar something.
Into the hell, Volhard Zelensky.
That's what you were going to go into. And you want to make this with that. End of class. It's not that bad.
So after we have this bromination,
It goes to the more substitute. Well, in this case, it goes there.
we have this, yes or no?
Yeah.
If we add a base to this, and I said it, you find it in your notes because this is upsetting. Find it in your notes. After we have this, we can treat it with a base. And I told you my lithium carbonate, yes? Yes or no? I said in your notes?
Yeah.
Yes.
I don't have to do it again. It's a waste of time. Whatever I do again, that means
You
I'm
can
going to
also
have to
use
be
pyridine.
faster in some other topic.
You also put pyridine as well.
Yeah, pyridine, whatever little not very strong base will do this job, okay?
And it'll give you an
And,
unsaturated.
and the reason for that is, you will pull a proton from here,
Yes.
and if you pull a proton from there, this will form. Why is that going to form? And I said it specifically because this is alpha beta
Alpha, beta,
unsaturated. It is
carbon,
conjugated to that carbonyl, yes?
Uh-huh.
I
Driven by
said that.
conjugation, yeah.
I said that, so I'm not gonna go through it again. I also said that where does it get attacked? If you had a carbon
VR.
here, for example, a carbon here, which would be formed first?
The one that makes the most substitute double bond.
The one that is a more substituted double bond, yes?
Mhm.
Yes or no?
Yeah.
We're gonna do more of that later. I think we were left off in the Hell, Volhard, Zelinsky. Is that it? Various steps. We're not gonna do the mechanism for that. We are just going to do some easy reactions, yes? Hopefully you guys did okay on that last test. Because you should be afraid of the next one.
Did you start grading yet?
No, not yet. This is called the Hell, just like Hellboy. Volhard. Zelinsky. Okay? What happened? Yeah. Vol.
Volhard.
Yes, Volhard. And this is a reaction of a carboxylic acid. For those of you that was this organic one? Maybe organic one. For those of you that took organic one, or what would that give you?
It's gonna give you.
VR where?
Where the
Acyl halide, yes?
Yeah.
But instead of being Cl here, it's just Br.
VR, yeah.
Okay? After that, so the purpose of this is to have a Br here. And what that is going to do, the Br here, of course this is acidic here, yes? So if you add a base, it will rather pull this proton off than this one, yes? When you put a Br here, this is going to acidify that more. So it's going to make this more acidic. And as a result, you are going to have the formation of the carboanion here, and is going to attack the Br3. I mean, Br3. That's fine. I'm having a bad day today. So, and after that, I need to get rid of the Br that was here, yes? And I need to add water to this again, okay? Yes? Is that clear? First step, I'm going to put a bromine here. The purpose of the bromine is
To make them worse.
to make the carbanion here. And after that, it's going to attack the Br just like it did before in alpha bromination, yes, or halogenation. But this is different starting material, yes? Last time it was a what? Aldehyde or ketone. This is a carboxylic acid, but this won't react. You got to change this to something else, which is an acyl halide, Br, write the product. And then after that, you add H2O, okay? We can say this is the first step and this is second step.
Right, the product.
Okay, so let's do this one on the top. This step with this step is going to give us what?
And
VR.
it's gonna give you.
It's going to give us a Br here.
Yeah.
This same step here is going to form the enol, or is going to form the way that we have been doing it here, the enol, one of the, what is it called, the resonance structures of the enol will have electron pair here, yes? That will attack the Br, and then you're gonna have tackle that later. What does this produce?
It gives you
It gives you alpha halogenation. In particular, in this case, is bromination. Do the one below. So what does this give you?
It's a bromine where the carboxylic acid is. It does.
Carboxylic acid stays where it was, yes? And you do alpha halogenation, yes? We can put the bromine here.
Yeah.
You want to put it on the top? Where on the top? Where on the top? Here? There?
Yeah, that's the same thing.
It's the same thing, okay? I mean, I put it down here because there was a little bit more space, yes? It'll look cuter down here. It doesn't really matter where you put it, okay? On the top or on the bottom, if it's alpha. This is carbon what? It's carbon alpha.
Yeah.
Let's do one of the ones you like to do, okay? And I want you to make that.
You need to use some special ingredients.
Yeah, you need some special ingredients, yeah. Like the soup from, what is it, what's that movie called?
Ratatouille?
No. Yeah, for the ratatouille, but the special ingredients from the, what is it, the panda?
Oh. Which one? Oh, Kung Fu Panda.
The father was using some special ingredients no one knew about.
Oh, man.
You guys don't watch that type of movie?
Yeah.
It's my favorite.
Hell yeah.
We spend too much time watching your videos.
That's now, man. That movie's old. It's not like it came out yesterday. What came out yesterday was the girl movie, right? The one with the night yesterday.
Inside Out.
Oh, the part 2 of
Oh, yeah. Oh, and the Minions too.
The Minions came out?
Huh?
The Minions are out?
Yeah.
No.
You saw it out yet?
Terminator. That's right.
Oh shit!
Terminator
Everyone
came
here
out?
watches Minions. Damn! I don't watch Minions. I stopped at Despicable Me.
Oh, Magic Mike came out yesterday, Professor.
What?
Ooh, I want to watch that. Magic Mike too.
Okay. XXL, yeah.
Yeah.
So that's just like Magic Mike. It's kind of like, hold up.
I'm not gonna go watch it. Not my style.
Why? Because you're on TV. Because you're on camera.
Not because I'm on camera. I don't care. But no, I'm not gonna go watch Magic Mike. I'm watching Magic Mike 4.
Learn some moves.
I want to watch Magic Michaela or something, right? Unless you want to be a stripper. You want to be a stripper?
Yeah.
They ain't gonna give money for you, man.
You can be like a special life.
Okay, guys, look here. Here is a carbon there, yes?
Yes.
And this one here has another carbon and a carboxylic acid at the end. If I have a carboxylic acid, can I do this alpha bromination somehow?
Yeah.
Yes, I can. So all I need to do is Add another carbon and
Carbon,
make a
yeah.
carboxylic acid there.
Right.
Do you know ways for that?
Yes.
Okay, good. What ways do you know?
You would do Grignard
Grignard?
and then
Grignard.
nitrile.
Grignard and
You could do
CO2?
nitro.
Or we can do
Nitro.
cyanide.
Yeah.
Okay.
Or you can do nitrile and H3O.
Some of you had issues on the test with cyanide, yes? Nitriles? So let's say I treat this with cyanide.
Yeah. Sodium?
Okay. Sodium, potassium, doesn't matter, okay? Cyanide is going to give us
CN. Yeah. CN.
You agree?
Yes. And then H3O.
And everybody got this on the test, yes? And how do you go from here to a carboxylic acid?
H3O plus.
H3O plus. Okay. And yeah, okay.
All right.
Good for you. Because, you know, I don't give you guys like little solvents and this and that, so I don't, you know, make it worse. And I don't give you heat if it's not a big deal. But we're gonna do one next. Then when you do eliminations, as I explained to you in Organic 1, when you do heat, most of the time it will be an elimination. So when I give you heat next, it will eliminate. Okay? So H3O will give you
Carboxylic acid.
the carboxylic acid
And then you just do the PB.
in this position.
Yeah.
And then how do I go here?
The PB.
Alpha
BR2,
halogenation,
H2O.
BR3, BR2 in the first step, and in the second step,
H2O.
H2O. Why is the H2O important?
To get
To get the whole
To get it back to a carboxylic acid.
Yeah.
Okay, very good. We could also do a Grignard from here, yes? We can also do this with Mg, yes?
Yeah.
And that's gonna give us MgBr here. We're gonna add CO2 on the second step.
Yeah.
Second step CO2, and this is going to give us this will be a minus, yes? And if we add a proton source, is it H plus or H2O is good enough? H2O? A little acid or a H2O is fine. So we're gonna say a source of H plus, and then BBr3, BR2 in the first step, and second step, H2O.
Why can't we do NBS anymore?
You want to do NBS?
Can you? Why would we want to do it?
We could, if we didn't start here, and if we were to start here, we could do
With a
NBS.
naked one, yeah.
We already has a PR.
Yeah, you can do, what is it called?
No, sorry.
Friedel-Crafts acylation, yes?
Alkylation.
Acylation?
Alkylation.
Oh, alkylation?
Yeah.
Okay, very good. Alkylation, you put a CH3, yes?
Yes.
Yeah.
And then
you do
NBS,
NBS.
and then you're here.
And then,
You
yeah.
don't need NBS now.
No, I mean NBS after you made the carboxylic acid. That wouldn't work?
No, that would not work
Why?
because it's an acid. It will make a mess.
So we're using PBr to produce carboxylic acid as opposed to Br2 and NaOH, right? But if we use PBr3 on a ketone, would it work? That one's the carboxylic acid.
Okay, let's do another one before we kill this one. Guys, if you have questions, you ask.
Alpha carboxylic acid.
Why can't the fox ever catch the roadrunner?
Why can't the fox ever catch?
The roadrunner. I mean, a coyote.
I think you've been watching too much Looney Tunes. You've been watching too much Looney Tunes.
It's your girls watch.
No, I only don't watch that. I only let them watch PBS Kids.
I'm a world girl.
Yeah, Word Girl.
And
Yeah, no, not the crap.
all crap. Crap. They were crap.
Yeah. And Martha Speaks.
Why did you put the same thing?
What's it gonna give you? I messed it up, okay?
Yeah.
It's so funny.
I was planning to do something and then I did something else and then I went back to it. So
It's
in other words, I behave like a girl. Look, I'm gonna put a B on here. There you go.
You just ruined the
What
problem.
happens to girls? Conflict.
What's the question?
Well,
Oh my God.
That's the
you
thing, like
missed
you
the whole
messed it
thing?
up.
I just spent 3 minutes talking about this.
No, I didn't catch it.
No, he just rewrote it again. So he messed it up. He wrote the product.
I was gonna ask you a question and then I kind of messed it up and then I compounded the situation until I just wrote it. Anyway, when you have it in your notes like that, you don't know if I did it on the board or if you did it or who did it, right? When you read it, it just all looks the same. You don't know if I did it or you did it. Okay, now,
Yes.
let's say we have this. What's the product to that?
I'm gonna give you a BR on the alpha position on the other side.
On the other side.
This is still alpha halogenation, but is this the hell
No,
boiler?
No.
no.
Which one is the hell bar?
PBR.
PBR3.
3, DR2, H2O.
Isn't it for carboxylic acid?
My watch is 27. So you are basically 37 minutes late.
Today, but I quit early.
No, I
For like the
understand.
past 2 weeks.
No, I know
For
you
like
had,
the past month.
you had to talk to your friend downstairs. It's important. Okay. So
Good morning
this,
to you too, Professor.
huh?
Good morning to you too.
Yeah. Okay.
Okay. So
I
for
still
the
like you the same.
I
So,
know.
the hell bolard is only for carboxylic acid.
yes.
So
Zelensky.
Guys, you know, are you guys memorizing the reagents and that's it? You
Yes.
gotta memorize the reactants. You gotta memorize what type of, if it's a ketone, if it's an aldehyde, if it's a carboxylic acid, if it's an ester. It's a big deal.
Yeah, it is.
They all don't react with each other just the same. They're different. The PBr3 is only for carboxylic acids. And I explained to you why it was only for carboxylic acids, because there is a need to form what? Acyl halide.
Yeah.
Yes? Now here, after you put a bromine here, here's what happens. This alpha proton becomes more acidic than it was without it. So there's another bromination or the possibility of another bromination. So you might get that. Now on the test, most of the time, I want you to give me only one, but I want you to know that you might get multiple brominations. And this is especially useful when you are brominating something called the methyl ketones. You ever heard of a methyl ketone? No?
Yeah.
So let's say we have that. Okay? This is a ketone, is it not? And this is a methyl ketone. And this methyl ketone with sodium hydroxide and Br2, first there's going to be a bromination on this carbon here. Yes? Alpha. And then that's going to make this more acidic. The sodium hydroxide is going to pull yet another one. It's going to brominate it again. And then it's going to do it again. How many times did it do it?
3 times.
It did it 3 times. Then this is going to form this CBr3. The CBr3 happens to be a good leaving group. And this is going to leave. Okay? And when it leaves, it is going to form, what do you think is going to form in the presence of acids and water and that? I
I'm
mean,
gonna put an enolate.
not acids, okay? but water. What is it going to form? Not an enolate.
Carboxylic acid.
It's going to form a carboxylic acid.
Because that is going to be a carbocation.
But isn't like the intermediate in phenolate?
Huh?
But what is it?
Yes, yes, of course. So what this is going to give you is a carboxylic acid with this CH3 here plus CH Br3. And this here is called the bromoform. And if you would have used, instead of Br2, you would have used Cl2, you would have gotten here chloroform. So this reaction is called haloform.
I have a question. So for in this case, for that one right there, we would only have to do the bromination once, but for methyl ketones, we have to do it 3 times over, right? So if I put that on the test, like
Okay,
2 bromos, is it wrong?
Okay, let's do this, okay?
If I put 2 bromos, is it still?
What's the product of that?
That's what I'm saying.
BR2,
Yeah.
2 BR is the same thing. Acid or base. Acid or base.
Same thing, yes?
Yeah.
Yes. Can this form here, bromo form here and leave? Can this leave here? It has to have
3
3 bromines on it,
bromines,
yes?
right? Yeah.
It's not bromoform. Okay? So in general, I want you to put 1 bromine on it, unless, but you have to know that you can get several bromines on it if under basic conditions.
Right.
On the test, I expect you to give me 1. Unless it is a methyl ketone, in which case I expect you to give me, not even 3. I expect you to give me a carboxylic acid.
It's a
I
methyl
understand
ketone.
how-
Got you.
What, you keep saying methyl ketone? So it can be any R group, or it has to be that word? Like, what makes it a methyl ketone? Now, which methyl? On the ring, or?
This is a ketone, yes?
Yeah.
Carbon, carbon. It's a ketone. And that happens to be a methyl. This is not a methyl. It's something else. That's a methyl ketone.
So it wouldn't work if it was 2 methyl, 2 C.
It could work, yeah, why not?
So then,
It has 6
then I don't understand what makes it a methyl ketone.
As opposed to what?
Like if there was 2 R groups as opposed to 2 CH3 groups, they wouldn't work. There needs to be at least 1 CH3.
It would not work, no. It has to have 3 alpha protons. So it can get brominated 3 times. Because the leaving group needs to have 3 of them there. For this, because the leaving group is going to be that's going to be the leaving group. If it doesn't have 3 there, it's not good enough. Okay? It has to be a methyl ketone.
Did you want us to know the mechanism for that?
Yes, I'm going to show you the mechanism. And of course, this is on the first step, yes? On the second step, you need some type of proton source. You can do it with water, but then the water might give you their carboxylate. So let's say this.
slamming their head in the door.
So what's this gonna give you?
It's gonna give you
Carboxylic acid with
with
CH3.
CH3, BR3.
Plus?
CH3,
CH3.
Okay. This is a mechanism for this.
For
Hollow form. So what we have here is a base, yes? This base is going to pull the alpha proton. The electrons from here are going to go to the carbon. They're actually going to go and form a double bond here to form the enolate, yes? But we're skipping that step, right? And I understand that it has a resonance structure. It's a minus, yes? Resonance structure for that looks like this. That goes there, that goes there. Yes or no? That's a resonance structure, yet we like to use this one, yes? Hello?
Yeah.
We like to use that one. I did the resonance structure for this. Redraw it. So I don't use this for two things. Yes? I redrew that one. And what is this going to do now?
Got one of those BRs.
And now this is going to attack
The VR.
the bromine. And that is going to take those electrons there to form you agree, yes or no? Hello?
Yes.
Now, under basic conditions, this happens to be now more acidic than it was before. So, the base is going to abstract that proton again. And you are going to get yes or no?
Yep.
Of course, this is plus Br minus, yes? Yeah.
After the first step, it goes down there to the other end.
Yeah,
Here?
yeah. That's just
I
one.
redrew this.
Oh,
This resonance structure, I redrew the same structure here to do the attack. So I don't do the attack from here, right? Because that would be confusing. Guys, what the problem is? This here, resonance structures of each other. That and this is the same thing. What?
Those two are the same, and then those two goes down here.
It doesn't go here. That is the same thing as those two.
He just redrew it.
I just redrew it, so I don't put arrows on the one that already has arrows. Right? This and this is the same. This has some arrow, that has different arrows. Okay? Now this is more acidic. It will pull a proton off again. And what do you get? Another attack. attacks the bromine. That leaves. This could get lengthy like this, yes?
Mm-hmm.
Br, another Br, a hydrogen. And now what's going to happen? Pull that off, goes there. R. That is going to attack another Br. Or I could have said, this happens 3x, yes? Or 2 more times.
Where do you put that?
Well, I showed it to you, so you wouldn't say I was holding back on you. On the test, if you do it once and you say 2x after that, so you did it once, 2 more times, and you give me this one here, that's fine with me. Okay? That one up there. And now what's going to happen now? It's going to leave, but it's not going to leave now. There is OH around, and this OH minus is going to attack now that carbonyl.
Yeah.
Oxygen
And
is going to
then
go to
that
the
leaves.
top.
Yeah, it's gonna be negative. And it's gonna go back down. And
That's going to be
negative.
negative here.
Yeah.
BR, BR, and BR, and now this OH. Yes?
Mm-hmm.
Now this is going to make a double bond here. The OH is not going to leave, otherwise it doesn't give you the product. It goes back to this, which then gets attacked again. I'm not saying the OH never leaves. I'm saying only when this leaves, it gives you the real product, yes? So now when that happens, that leaves, takes the electrons with it. So that is going to give you double bond to the oxygen, yes? And that left, the OH stayed there, plus, you agree, yes or no? Okay. Now, of course, this is a carbonion, and that is acidic. So that is going to take that hydrogen out. And the electrons from here are going to go to the oxygen. And what you are going to have is this. Plus bromophore. And then this is why there is a need to add water or a proton source. Okay? So you can add water or something else you'll take a proton from. Okay? Now if it's not very acidic, so it's an equilibrium, yes? But I don't care. So let's say I'm going to write protonation. Protonation.
Why doesn't the CBR3 take another H from the proton source itself? Like, why does it have to attack
That's a good
the
question.
nucleic acid? We have proton sources in there.
We don't have proton sources. If we had proton sources, the reaction will not go anywhere.
Oh, you added that. So.
Yeah, you add it after. You let this happen for a day. Okay? Up to here for a day. Okay? If you add a proton source, at any point, that will take the proton source, or, you know, or this will take it, and it's not going to work anymore. There's no base for this to happen again and again. Okay? The proton source is only added at the end of the reaction, when that is what you are expected to have, and this is what you get. But you are right. If you added a proton source at this step here, that would take. But whenever you make this, it's going to take it from there. So
Yeah.
as long as you have this, it will immediately take it from here, so you always have this. And if you don't have this, then that means you have that. And if that leaves, then you never get the product. You want that mechanism on the test?
Yes. Yes. Yes.
They're all easy because you guys are state-of-the-art instruments now.
Yeah.
You got complimented
Yesterday.
by Dr. Jimenez.
Yeah.
She was like, oh my.
They all know the mechanism,
She
right?
Garcia must teach you guys mechanism very well. You guys are my best class for mechanism.
Damn right.
Yeah.
That's how we roll.
Right.
I don't want to say more because it's public knowledge.
Is it hot in here?
Hot in here?
I'm just saying.
No, I'm actually cold. What?
Yeah, it's really.
Okay, guys. You want to do another one?
Yes.
So first step, sodium hydroxide, Br2. Second step, proton source. Proton source in general, not from HCl, yes? Proton source in general from H2SO4. Something that is not very nucleophilic.
Professor.
You still doing that mechanism over there?
Yes.
Yeah.
Why did the CH3BR disappear once you added the protons?
Disappeared?
It didn't disappear.
What do you mean disappeared?
Because you didn't write.
It didn't
So what? I didn't write it. It did not disappear. Nothing disappears.
Do you worry about about the inorganic product? Like you always say.
Guys, this is called the bromoform, yes?
Uh-huh.
Still here. But it's still in the same form as that, yes?
Yeah.
I only give you what the transformation was. Okay, the bromoform is still there. This is a test on your lab, yes? Haloform reaction
Yeah.
to see if you have methyl ketones.
Iodoform, that's what we use.
Iodoform.
You use iodoform
Yeah.
and it precipitated.
White. Yeah, yellow.
Yellowish.
Right.
The
Yeah.
yellowish, yeah, that crap.
Yeah, yeah.
Yellowish precipitate.
Okay, guys. What happens here? What? Guys, speak.
Yo, each attack
Oh,
on the
carboxylic acid.
No, tell me the product. I
Oh,
want
the carboxylic acid.
Carboxylic acid
Carboxylic
with
acid.
CH.
carboxylic
The
acid plus
CHBr3 bromoform.
What is
Bromoform.
I said fluoroform.
Okay. Now you have another way of making a carboxylic acid that is not like that, yes? Well, how do you make a carboxylic acid
From that,
on a benzene ring with carbons or?
Na2 Cl2O7.
You can do chromic acid, yes?
Yeah.
Yeah.
Chromic acid.
You can do potassium permanganate.
Yeah.
Uh-huh.
On a ring? Or has to have?
No, on the groups attached to the
Oh,
ring.
okay.
Na2 Cr2O7.
On something similar to this, yes? Don't erase the top. Okay, I guess I can do it there.
What did you eat?
Let's try to do.
We already did it. Well, it's just different. It's the same concept.
Let's try to make you feel good about how much chemistry you know. You start with that alcohol.
That's a nice thing. You like a little baby?
I'm not gonna lose these, right? I could have made that harder. Yeah.
Were you asking how to get it from there?
Yeah. Synthesize the thing. Ether.
OCH. Yeah, S for sorry.
Okay, first of all, you look here, right? You look here, and how many carbons are here? 1, 2, 3, 4, 5, yes?
Let me see. Sorry.
1, 2, 3, 4, 5. And next to that OH is that thing there, yes? Which is that thing here. So this has 1, 2, 3, 4. We lost a carbon. How do we lose a carbon? Of course, this has to be.
1, 2, 3, 4. Yeah, but the end of 1, 2, 3, 4, 5.
Guys, did we lose a carbon? Yes or no?
Yes.
We lost a carbon. And this carbon is on one side of this oxygen here. But you have to know, an OH, it is always related to what? An alcohol is related to a carbonyl, and a carbonyl is related to an alcohol, yes? Because I can oxidize this from this alcohol to a carbonyl. So if I oxidize this alcohol to a carbonyl, this will be a ketone. And we know that we can lose a methyl ketone. We can lose that carbon from a methyl ketone. And if we lose that carbon from a methyl ketone, what does it give us? A carboxylic acid. And can we convert a carboxylic acid to an ester after that?
Yes.
Okay, you try to do it.
Yes. OH is OH plus, which makes this. Yeah. So it'll be ethyl.
Okay, let's do it, guys. Let's do it. It's taking too long. In the first step, what am I going to do? Oxidation, yes? With?
Yeah. You could do PCC, you could do Na2 chromic acid, all that.
Yeah, PCC.
BCC, yes?
Yeah, you could do PCC.
PCC
What?
is going to take you straight to the doctor.
Who's waiting
No.
for me?
What's not? PCC don't take you there.
No, that's okay. Yeah.
PCC is usually.
Let him laugh. He's people. He's always laughing, man. Mr. USA, yeah? So here's BCC, yes? BCC will oxidize a secondary alcohol to a ketone. So I have a ketone. This ketone here is this ketone.
If it was primary, then it would be,
It's a methyl ketone. And now that I have a methyl ketone, I have a way of getting rid of that CH3. And this is used in what reaction?
Sentence.
Bromoform, yes? Hello?
Isn't it?
Yeah. I am going to add sodium hydroxide,
Br2
Br2,
and
in the third step.
H2O or
H3O
a proton
plus.
source.
It needs a
Proton
Proton
source,
source,
okay,
yeah.
fine.
And
Whatever.
then,
So in the fourth step,
then
Alcohol.
you put
I have a
alcohol.
carboxylic acid,
Uh-huh.
and now I need to
ETOH.
lose that OH and put that there, so that happens to be
Ethyl.
methyl, so
ETOH.
ETOH. And you need the H plus.
an H plus.
Kill.
Yeah? You got that?
Yeah.
I needed this carbon here. I needed this carbon here to have these groups there because
They would have it on that side, it's more something.
if it had it on that side and it had it on this side, it will be a mess, yes?
Yeah.
If it had hydrogens here, it will pull off from here. So most of the time, the methyl ketones that we're looking for, it's one methyl group, and then the other one is a carbon with no alpha hydrogens, okay? You want to try another one of that type?
If it had an 8, wait, if it had a,
let's say, H.
No one seems to like Oreos anymore.
wait, okay, so we had, okay.
Yeah, methyl, you take it out.
If it was just, if it was primary, that alcohol was primary. Then we would use if you do the chromate or the KMNO4, it'll be a carboxylic.
Isn't that anybody that knows it's like
Yeah. Oh gosh. That look like
feel me?
it could be Vedic too.
Okay, look.
the left? You get what I'm saying?
Let's change this to something else. Because, you know, that'll be sort of like that.
If you do, yeah, because if you do hydroboration, it'll
It's
give you
gonna give you the alcohol.
anti-McCormickal.
It'll give you the alcohol.
Yeah, if you do hydroboration. Right, if you do hydroboration.
Now, this is a hard one, okay? This is a hard one.
Okay, isn't it?
Huh? You can use McCormickal for anti-McCormickal.
No?
You cannot use it because you will keep this carbon. You see,
Oh, we lost
there is a carbon here.
Yeah.
Yeah,
This
that's
carbon
right.
is gone.
That's right.
And that carbon is gone too.
We
Yeah.
lost two.
So if I do addition here of OH anywhere, that carbon will stay. I need to get rid of this carbon. I have to use something that is going to cleave that double bond. Like ozonolysis is going to cleave that double bond. I got to cut it. If I don't cut it, this is not going to work. So ozonolysis
Yeah, it's
is a
a
choice
ketone.
when you want to cleave things, yes?
That's right.
Ozonolysis. And the reason why I'm giving you this problem is so you remember that, okay? So, ozonolysis, and then what are you gonna add after that?
DMS.
DMS.
I give you a ketone.
And what that is going to do is going to cut this here
Yeah.
and put oxygens,
Uh-huh.
yes? So, it's gonna put an oxygen there. You agree?
Yes.
Plus an oxygen in the other one. Yes or no?
Yeah.
And then after, now I have what again? Methyl ketone. So it's the same thing as that, but different, right?
Yeah.
Different because we have a methyl ketone. Now we are gonna do this.
CO2. CO2.
Br2.
No, wouldn't
No,
it be
CO2.
CL2?
CO2.
No, you carboxylic base,
You gotta
SOCO2.
take out.
Yeah, it wouldn't matter, that's right. It wouldn't matter, you can do CO2, doesn't matter. This is gonna be gone, yes?
Yeah.
It's gone, it's gone.
Yeah, just to make it.
If you write BR2 and CO2, it will be fine.
Okay.
It's gone anyway. And then after that,
Yeah.
we got this, and then we will have, after these two steps, this is what we're gonna have.
Carboxylic acid.
Now, if we wanted the ester, we did that, but now we don't want the ester, we want the chloride.
CLT.
SOCO2.
So in the fourth step here, we're gonna add
SOC.
SOCO2 for that chloride.
Nice. So this, yeah, because the BR2 is just to make it leave. So it don't even matter. You can use BR or CL. It don't matter. Just to make it leave. Got
You can use I, you can use BR, you can use CL.
Got you.
Use it now.
All right.
If you use I, it's called iodoform. If you use B, it's called bromoform. If you use C, it's chloroform. I mean B, no. Like I told you, I'm not having a good day.
When you're doing ozonolysis, how do you choose, like, I mean, obviously I know which one we want to use, but how do you show, like, on the paper that you're picking one over the other?
Because I know. Because when you do it, I know what you're trying to do if you're doing it right.
Or, like, in the lab, how do you, because you get both, right? So how,
You get both, but you don't care about both. You only care about one. You only care about what you care about.
right.
And what we care about is this, because this is what's gonna get us to the whole thing. This thing we are going to call an impurity. This thing we're gonna call a byproduct.
Byproduct.
This thing we're gonna call roadkill. You know, we don't want it.
Impurity. Impurity. Roadkill.
I have to drive through a puddle of water, so my tires are so.
Okay? Guys, you want another one?
What was it?
Let me give you another one.
A dead what?
It was a dead rat. But it was already like,
Oh, rat.
yeah, but it was kind of fluffy, and then like I passed it.
After we're done with the next chapter,
It was
I want you to go online and find the structure of methamphetamine and see if you can make it from reactions we have done here.
Starting
Hey, I know.
Starting from the thing you can make, starting from, let's say, benzene.
I know a certain student that watched a certain show. Now that certain student is infatuated with
I
methamphetamine.
already tried to do it.
You already tried?
The way I was doing it, I don't know how to break a double bond between the carbon and the nitrogen and make it single. Without,
You do.
I do now.
Yeah, you do now.
I figured it out.
You can do reduction of that double bond. But it's better if we do nitrogen containing compounds on these, which is the next one. And of course, I'm gonna tell you something, okay? Maybe I shouldn't say this. No, I'm not gonna say it.
We could pause it. We could pause it.
I'm already in trouble with the cops, you know?
The new Walter White.
He's still on camera with us.
Eisenberg.
You could get methamphetamine, and you could, I mean, the nitrogen will cause a problem for some of the electrophilic aromatic stuff. But if you put another group there, it might have the same effect, but then the metabolites are not the same. So when you do NMR and mass spec, and you get a sample of a person's urine or blood, the peaks are not gonna be there. So the library, you're not gonna get a hit for the library. So.
the library.
Let us work for you.
That's why I don't understand. This guy, what's his name? Lance Armstrong.
Yes. Yeah.
They did not catch him doing it, right? They did not catch him doing it. And he was doing it probably during the thing.
Chemo.
But they did not catch him do it because the chemist that was giving him the drugs or making the drugs was changing them. So when you inject it in the mass spec, you know what mass spec is, mass spectrometry?
Don't worry about it, okay? We're gonna have a class, but let's say you have peaks on the thing. And the peaks are molecular ions peak. They're for molecular weight. And let's say that I have cocaine, yes? The peaks, cocaine or testosterone or whatever, the peaks are here. Those are the peaks. And they have a library. A library means a machine inside knows if the peaks are these, then it is cocaine, right? But if you manipulate this and you change the peaks, let's say by a methyl group, or you change one of these peaks and now it is here, and this one is here, and this one is here, then they don't have a library for that. So when they get it, when they run it, they don't get a hit.
But do you still get high, like off the same thing?
You might, if it is the same, if it has the same effect. That's why you gotta make it and you gotta test it. Not with cocaine, but I'm pretty sure that those people that are high level athletes, right?
Yeah.
They're getting the testosterone, they're changing it here and there, and then they're confusing the machine and they can't get it. Now after the blood has been there for a while, it's gone, right?
True.
The only way that people are gonna know you did it if somebody snitches on you.
Yeah. So that's what the chemist came out and told, huh?
No, the chemists never come out and tell you.
Okay.
You ain't learned?
You know how much money they're making?
The ones that tell are his friends. The ones that told.
Okay.
Yeah.
Yes, sir.
It wasn't a chemist, man.
It's kind of like a ghost
You wanna
chemist.
keep-
You never know who it is.
You want to keep making it.
Plus, the chemist that did that, you don't even know who did it. I'm pretty sure they had a guy saying, "Oh yeah, I'm making it," but the real guy is in the background making it, and he's not saying. So that's the way to do it.
But can't you get in a lot of trouble? So his whole life is at risk, his job, everything, right?
For the chemist?
Yeah. If he, and let's say if he does get caught, that sucks, no?
Yeah. Well, I mean, if he is a normal person, like I have a job, yes, here. But if I didn't have this job and I was on the streets, then I could do whatever I want, right? What am I losing? If I do it here, I'm losing my job here, yes?
Yeah.
But you think the people in Mexico and Colombia don't have chemists doing that type of stuff? They set up the labs, my friends.
If I see you on the news 20 years from now, all I was saying, yes! That man was my professor. Legendary.
He's like, let me go back to this
right
shit.
now.
He's like, let me go back to this. Oh my god.
Okay, guys.
So, what is this? We have a... Is that right on the top?
Is that what?
Right?
Right?
Yeah. It looks funky. I know it's an email. Right? Why couldn't you make it to like a hydrazone or something? Right?
You could. But why make it so hard? If simple is hard enough.
Yeah, because I don't know what's going
The
on.
purpose is not for you to get it wrong.
The purpose is to get it wrong so we understand it.
No, if I make everything for you to get it wrong, I'm going to pass the class. So, what's that? Is that a enamine?
No.
It's not an enamine.
Enemy had two.
Imine.
Is it a hydroxine?
No.
Imine.
I-M-I-N-E.
Is it a hydrazine? Is it a hydrozone?
Oh yeah. And my dog did.
So what is it?
Which one? That's an imine.
No, that's an amide. I'm talking about the reactant, my friend. An imine, yes?
Yes.
Imine?
Yeah.
Okay. And you notice that next to this functional group on one side, you need one carbon less, yes?
Yes.
Next to this functional group on this side, I have a methyl. I can get rid of this methyl. Yes?
Yeah.
This needs to be what though? That needs to be a ketone. What that means is I have to get rid of this and make a ketone from here. I didn't make a ketone from here.
Yeah, water. Water.
Yeah, water on a proton source, right? Yeah, water on a proton source. The same way you made it is the same way you take it off. Okay? Because these reactions are what?
Reversible.
Equilibrium, yes? Okay, so we are going to treat this with, okay, you try to do it. H3O plus is gonna give me the ketone, yes, methyl ketone. In the second step, this is a methyl ketone. What am I gonna do here? PBr3, yes?
Yes.
PBr3 and Br2, right? Hello?
Yes.
PBr3?
No.
So why are you saying yes?
BR2 and H3O plus.
No, I don't want you to follow me. I want you to say, no, Professor, that's not what you said before. If you're paying attention, of course, none of you were, yes? Including Miss Aduarca here.
Claire finished it.
She was the first one that, yeah. Move on, I want to go home.
How do you know?
Oh,
Okay? And so this step is going to give me the methyl ketone. This step is going to give me the carboxylic acid.
Yeah.
And now I need to make an amide from that. And what am I going to add?
NH3.
Can you go from
NH3,
carboxylic
huh?
acid to NH2 and
What?
Can you go from carboxylic acid to amide? Or you do it with
You
SSL
can.
to then do
We did that last.
You could do that, Chuck. And you can do this one straight too.
You could do that one straight?
Yeah, did that last.
Yeah. Now, guys, you know, because you brought this up, yes? If you add NH3 to either one of these, you are going to make this.
Okay.
To either one of them, you're going to make it. The only difference is, which one is more reactive?
That one.
The CL,
This one is more
right?
reactive.
Yeah.
But this would require you to do another step, yes?
Yeah.
But
Excess.
this will almost go the same reactions this way,
Yeah.
okay? Not always, but almost the same, at least with these. Okay, well, we beat that one to death, completely. Beat it to a pulp. Feel the need to make noise, or
Just hyperactive.
let's do this one. Aldo, you know that place that sells shoes, yes? Aldo?
Yeah.
Aldo, that's my favorite
Good
shoe.
shoes, man. I
I
ain't
love those shoes. And they cheap too.
Professor Garcia, don't tell me you go to Aldo too.
cheap if they good.
What?
You go to Aldo?
I go to KOD.
KOD.
Okay. So,
Aldo's when you have a ketone and an alcohol.
Go to KOD. That's Garcia.
let's say we
I
have
don't think you
this.
go in there.
Let's say I add sodium hydroxide to that. I add sodium hydroxide to that, or I add a base to this, yes? Now this reaction is going to go back and forth. Yes, back and forth. If I add a base to this, what is it going to form? It is going to form the enol. Yes or no? Do you agree? No?
Yes.
It's going to form the enol.
Yeah, that's right.
This
that's right.
enol is going to do an attack of another one of its type that is not an enol. It's going to attack that one. Okay? And when it attacks it, that goes up. And what you are going to form is something like this. There is going to be that carbonyl stayed in its place. Because this carbonyl is the one that had the carbonion on it. So that stays the same. The one that loses the carbonyl is this one that gets attacked to form. What does that form if it gets attacked? By any nucleophile. No? Guys, if a green yard attacked that, what would it form?
Alcohol.
An alcohol. It's not a green yard, yes?
No.
But it's still carbonion, yes?
Oh yeah, that's right.
It attacks it and it forms the
Tertiary
same
alcohol.
thing. It is going to attack it, and it is going to form an alcohol here. Okay? Alcohol with this, of course, there's let's not draw it like this. Let's do this.
Oh, secondary alcohol.
Where,
That one.
oh, there's an H, right?
Wait. Wait, Professor, how did you get the bottom? Does it seem like your attack itself? Is that what's going on?
What do you mean? Yes, it attacks, not itself, it attacks the
Another.
carbon anion, the enolate attacks itself when it's not in an enolate form.
Oh, okay.
So yes, it attacks itself. So this is aldol, and what does it produce?
This is a 1, 2, 3 functional group.
Aldehyde.
Carbonyl.
Carbonyl. Yeah.
And
Alcohol.
in the third carbon, you have an alcohol.
Hydrox. Yeah.
Okay? So this is beta hydroxy, yes?
Beta hydroxy.
Beta hydroxy. Let's do another one, see if you can figure this out. Guys, back and forth, yes?
Yes, sir.
Of course, sodium hydroxide is pellets, yes? There has to be water in there. Okay, now what? Now these are not so easy to draw, yes? Or they are easy? They're easy to draw? Maybe they're easy for you. So here's what you're going to do. Sodium hydroxide is going to do what? It is going to pull this proton from here. You are going to redraw the same structure. So I am going to redraw this. You agree, yes or no?
Mm-hmm.
Now, it pulled it off from here. And this thing here will attack another one of these. Yes? So it will make a bond where? It will make a bond from here to this one here. It will make a bond to this carbon. And this carbon had a carbonyl before.
Mm-hmm.
But after it made a bond to it, it's no longer a carbonyl. What is it now? It is an alcohol. And then you write, because you are on this carbon here, an OH on one side, it does have a hydrogen, but it has 1, 2, and 3 carbons on it. Is that 1, 2, 3 or no? 1, 2, 3, 4. That's total of 4, yes? Is this one part of the one that got attacked or no? This is the carbonyl. 1, 2, 3, 4. This is the carbonyl. 1, 2, 3. I'm missing one. Yes. What? That's not what you did? Let me see what you did. Maybe you did it right. Okay, but that's fine. What you did might have been fine. That's what she did. Okay, this is once again 1, 2, 3. Yes? She did this, yes? So here is, would that be okay? Kind of okay, right? What else? This is, where the carbonyl was, had 1, 2, 1, 2, 3, 4. I mean, 1, 2, 3, 4. So this had 1, 2, 3, 4. Yes or no? Or no?
1, 2, 3. What?
Which is the alpha carbon in that
No,
structure?
in the middle.
That's right, this is the alpha carbon. This group belongs to which one? This group belongs to this carbonyl.
Yeah, the beta.
From the carbon that was the one that was attached.
This is the alpha carbon that the new attachment was made. This is the alpha carbon of the original one that had 1, 2, 3, and 4. So 1, 2, 3, and 4, it's not this way. It is 1, 2, 3, and 4. 1, 2, 3, and 4. Yes? This bond here is which one? It is the bond between this carbonyl and that alpha proton. Yes? Here's the alpha. Here's the, not alpha proton, alpha carbon. So 4 after this. 1, 2, 3, 4. 1, 2, 3, 4. Is that what you did?
I was missing
The other little sticks, yes. You guys want to try another one?
Yes.
What? Wait. Look, we have two choices. We either try another one or we can do a retro Aldo.
Let's try a retro.
Why do you think that
Cause man, we already did this. You got it.
I got you in the car.
she was talking about this? That's gonna be in this room. Kitty. So can we write it both ways like that? Like that?
Yeah. Which way do you like to draw it? The one on the top with a 1, 2, 3 that looks like what I showed you before, or the one on the bottom that is obtained from the structure that you redrew from before?
The one to the left, the bottom one.
One on the bottom.
Yeah, because I don't.
They're both equally hard?
The first one is
The first one.
Okay, try to do this one, okay? What day is today? Thursday? We're going to be finished with this chapter next week. We're going to start on amines. You will have a test soon after that. So,
Wait, what did you say?
I didn't say it.
Something.
You heard wrong. Okay, which structure do you want me to draw first? Let's do both. Look, I am going to redraw it the same way on this one. Yes or no? Hello?
Yes.
And I am going to put the new incoming group on what position? On the alpha position. This will have a bond. This bond to this carbon will have the OH. And this will be 1, 2, 3. Yes or no? Now, this, the rest of this, it is the rest of that. Yes? And the rest of that is a carbon with that on it. It's a carbon. Yes? It's a carbon with that on it.
But and then you're missing an H.
What?
Missing an H?
Yeah.
I know.
You
Where?
need to draw it.
Yeah,
You don't need to.
Where? There's H's all over the place, but
But there was one that you drew in the first one that you didn't draw.
you mean here? You want to draw an H here?
Yeah.
Okay. Draw it there. Okay, if we draw it the other way, let's say you want to draw it this way. Let's say you want to draw it that way. What carbon is this?
Alpha.
That's the alpha carbon, yes?
Yeah.
That's this carbon. What does it have on it? Another carbon.
Yeah, with an alcohol.
Another carbon with that thing on it. Yes or no? Hello? That's what this is, right? Carbonyl, carbon bonded to the OH. I mean, not bonded to the carbon, bonded to another carbon with the OH. And then the chicken, which is what that is, yeah? Chicken leg. All right. So if I am going to finish writing stuff on the OH, yes? The OH is this one, yes? Which is that carbon. What does it have? It has this carbon that has the chicken leg. Here. Yes, is that it? Oxygen, CH2, T-butyl. Oxygen, CH2, T-butyl.
That's all right.
Guys, look. I'm not gonna lie to you. These are difficult to see, okay? They are difficult to see. If I make this multiple choice, you gotta understand the structure I give you. So it's not the structure you draw, but the structure I give you. So you gotta understand the structures, and you gotta make it yourself, because I don't know if we're gonna make the next test multiple choice or not. Okay? You don't like a multiple choice?
For this stuff, it's probably better we can't draw.
For this?
Because if it's multiple choice and we're limited to the way the answers are. Because if you draw that and you don't understand the bottom one, even though they're equivalent.
Yeah. I'll start making the test.
Now?
Yeah. I'm gonna start making the test. When I teach you something, but sometimes that happens to be a very hard test when I do that. Because I teach you something, I have it fresh in my mind, I know what I taught you, so I tend to make a question that is good for the whole class, but you don't find that good. Okay, whatever. I'll see you guys next class.